Okay. So I started the training. Why did I click start immediately? Anyway, here is our CNN sample, right? So notice I have the same sort of boilerplate code to fetch fashion MNIST. We can just actually delete that one entirely. I have a slightly different function for preparing the data, right? I'm mapping a different function. It is, instead of outputting the label, outputting the same thing as the image, because to demonstrate the upsampling, I am reconstructing the original input, right? I'm mapping 28 by 28 by 1 to 28 by 28 by 1. So to do that, the desired behavior and the input need to both be the same image. So here I've got my 28 by 28 by 1 input. Don't need that. I've got my convolution layer. I've got my ELU activation. Notice that I, for no intelligent reason, decided to have 12 filters, right? 12 feature maps, 12 filters, 12 image planes. And each one of those filters was going to be 5 by 5. I then did a 2 by 2 max pool, and then I immediately reversed it, which in any real scenario is not brilliant, but with a upsample, right? 2 by 2 upsample. And then I immediately performed an inverse transpose and performed the ELU on that. And that, again, is back to being 28 by 28 by 1. And if we scroll up, so this time I call model.summary. That resulted in this. And we can see that it is telling me all of my layers, right? All of my layer sizes. Oh, okay, good. I wasn't off by 1, right? 24 by 24 by 12, which makes sense, right? 12 is the number of convolutions, and it should be 24 because that's 28 minus 5 minus 1, right? And it works out to 312 parameters. If you do the math, that might not turn out to be the number you would think. That is because I believe these convolutions are also biased. There is a biased unit. So there will be 12 more parameters, right? One for each of the 12 filters. And then my max pool, right, reduces the size of that. So the activation is the same shape, right? The convo is 24 by 24 by 12. The activation is 24 by 24 by 12. The activation, of course, has no parameters, right? The max pool shrinks it, right? Halves it along each axis, so now it's 12 by 12. That's a significant reduction in parameters, right? And then the upsampling immediately doubles it again, right? Because I did 2 by 2 upsample. And then the transposed convolution immediately expands it back to 28 by 2. Sorry, that was just a Linux thing. Immediately makes it 28 by... On Linux systems, middle click is a paste, and I middle clicked by mistake, which is why a bunch of garbage got pasted in. That immediately expands it back to 28 by 28 by 1, and then the last activation is 28 by 28 by 1. Total parameters are the two convo layers, the convo and the inversed convo, right? So even though we might have more units on a bunch of these layers, and even though, as you can see, the computation is kind of expensive, right? There are only about 630, why only, it says right there, there are only 613 parameters, right? That is not a lot of parameters, okay? And it is now chugging along. Notice I compile it, I get my history, I print my history, and then I save this thing as an HDF5, right? Yeah, so even though there aren't a lot of parameters involved, there is a fair amount of math involved in computing the activation at each layer, and so we are going to be here a minute. All right, so you might hear a cat eating and tea microwaving behind me. We can see that training has finished. Loss got fairly small. That is MSE loss. Should be MSE loss, actually. I hope I used MSE. Yeah, good MSE. All right. So now I'm also going to demonstrate this. That should be load, but whatever. This function to load the model. It proceeds much the same. We import our various libraries. We load fashion MNIST again, because I'll be testing on that. I repeat exactly the same data preprocessing, right? Because your model is trained on a certain kind of data, so whatever you do to process the training set, you should also do to process all of your test and input, like all of your test set and all of your real-world input, right? Because your model expects, well, expect shouldn't anthropomorphize it, but your model expects certain statistical regularities that you should ensure are present. Oh, I butchered that sentence. All right. And we notice that instead of building the model and training it, I now just keras.models.load the thing that I saved earlier. Right? Here I saved it as inverse.h5. And here I'm loading it as inverse.h5. Because it's using the inverse functions, I'm going to print a summary, and then I will evaluate it on the test set, and I'll print a layer shape just to convince myself that I can. If I click run, we see it outputs this. This looks the same as this. This was the copy from before when we trained. Whoops. This is the copy from before when we trained. This is the copy from when we loaded in the other model, right? Total params are the same. We have one pass through it because we're testing on the data once. Why do we only have one pass? Because testing is completely deterministic, and testing on the test set repeatedly would produce the exact same answer, right? No parameter updates are happening. The same math is occurring every single time. The result will be the same every single time, right? You see that my loss over the test set is 0.0095. That's my mean squared error loss. That seems fairly good, although I would like to see what those reconstructions look like. I would not be surprised if that ends up being very good, because we only have one convolution layer, right? Very loosely speaking, what I'm trying to do, so I should have said this earlier, right? But what I'm trying to do is I have my image, right? I'm performing convolutions, I'm subsampling, and then I'm going backwards, right? I'm upsampling, and then performing inverse convolutions, and I'm trying to get the output to match the input. Well, that would only happen, so basically the output would only not match the input if I threw away a lot of data, and I'm not throwing away a lot of data, right? I only have this one operation that doesn't narrow it by much, and this one sort of chokehold, or bottleneck, better, right? Choke point, well, gosh, right? This one choke point or bottleneck, right, where a lot of information gets thrown away, which is the upsample, or which is the subsample, then upsample, right? So with that one major bottleneck, I would kind of expect it to learn to reconstruct fairly well, and indeed, it seems like it does. Right? And then, to top it all off, we pick randomly layer 1 and look at the shape of it, and there we go. So, just 2, we can, in theory I could type, we can type model.layers. There are all of our layers, right, in a list. So layer 1 is that first convolution layer, so that's the size we're seeing. Okay. Just for completeness sake, model.layers 1 is that convolutional layer. And that is convolutions, complete with a short demonstration of saving and loading, because I can't believe I totally forgot that you needed to know that. Next week, the last I checked, it looks like LSTM was, I think, 3, and then SNN was 2 or 3. If I have to break that tie, I'll probably do LSTMs first, because people are going to need those, right? LSTMs are a text. So if you do a text project, you'll need LSTMs, right? Autoencoders was on the list. I might skip autoencoders, and the reason being this is one. So up to a point, how much discussion do we need to have? There are things to say about. So an autoencoder is basically, as the name kind of implies, a network that reproduces its input, right? So that's this. You're essentially looking at an autoencoder. Now, I say rhetorically, how much is there to say? There actually are useful things to say about autoencoders. They just might not be important enough for me to spend time on it if we get pressed. Especially not if you give me the option of SNNs, because I like SNNs, right? Okay, yeah, I think that is everything. Here is, we'll probably do either LSTMs or SNNs next week. I might put up another poll, or I might just go with the second place from this one. Please be working on your projects. If you don't have a project idea, you really should get in touch with me quickly. Pick one of the example projects. I'm going to warn you right now, every semester somebody says, oh, I couldn't pick an idea. That is not an excuse, okay? Have your project started. Be working on it. If you're having trouble picking, look at the examples and or talk to me, okay? Please. Please be working on your projects. And that is everything, I think. Stop recording.